In lesson 5.3, we're going to talk about some properties for kites and trapezoids. First of all, as we look at a kite, I know that the non-vertex angles are congruent. So if I look at what that means, non-vertex angles are the ones that we're talking about right here and right here highlighted in the pink. These are the non-vertex angles. That would be angle KEI and angle KIT. So KET and KIT, pardon me. And that would be the same as these over here. I also know that the diagonals are perpendicular. So as I look at those diagonals being perpendicular, that's talking about, I see that this diagonal in purple is perpendicular to this diagonal. You can see the little box there. I also know that the diagonal that's connecting the vertex angles is the perpendicular bisector of the other diagonal. So not only is it perpendicular, but it's also the bisector. So what that means is, as the diagonal that's vertical is coming down, it chops the resulting other diagonal into two equal pieces. Or in other words, in the picture, we know that ES is congruent to IS, as well as being perpendicular to that. So we have that little box here that shows that they're perpendicular. And we know that the vertex angles are bisected. So as I look at the vertex angles being bisected, what that means is that I know that not only is the set up on the top here congruent to each other, but the set down on the bottom are congruent to each other. So for example, perhaps, let's say the top angles are 45 degrees each, and the bottom angles are 20 degrees each, as an explanation of what's going on there. So all of these properties are going on inside of a kite. In addition to that, I also know that the disjoint pair of consecutive sides are congruent. That means that KE is congruent to KI, and ET is congruent to IT. So lots of different things going on inside of a kite, lots of properties. In a trapezoid, we have lots of properties that happen as well. So if I look at maybe the first property, consecutive angles are supplementary. If I were to write some angle measurements in, like for example, 60 degrees here, then I know that this has to be 120 for this angle. Also, in an isosceles trapezoid, base angles are congruent. So I know that these are 60 degrees and equal, and those are 120. Also, probably most importantly in a trapezoid, there is one set of parallel sides that I have. So as I look at the bases, I see that they are parallel to each other. Again, I know that the consecutive angles between the bases are supplementary. So on the one to the right, which is not an isosceles trapezoid, my angles could have been something like 120 here, 60 here, 80 down here, and 100 here. So these two angles are supplementary, and these two angles are supplementary, going back to the red information. In the isosceles trapezoid, in addition to these things, we also notice that the non-base sides are congruent to each other. That means this side on the left, TA, and this side on the right, RP, are congruent. We know that the base angles are congruent. We already talked about that. The base angles would be the fact that angle T and angle R are congruent. So here's T and here's R. And also angle A and angle P are congruent. This is angle A, this is angle P. The other last neat thing about isosceles trapezoids is that the diagonals are congruent. So diagonal TP and diagonal RA are congruent to each other. So lots of interesting things happening inside of an isosceles trapezoid. If it's not isosceles, then the most important thing is that we have two sides that are parallel, and the angles which separate the bases are supplementary.